Swayam Prabha. Digital India. Educated India.
Welcome back. So in previous lecture we discussed about different type of plate boundaries and tried my best to explain you. Now further, this was the last slide where we stopped. Now the arrows which have been shown here are the plate motion. Now this has helped us in understanding that how different plates are moving and with different velocities. This is very important finding, and the measurements which have been done by GPS, and most of the countries now are having a very good network. Even in India, we are deploying as many as GPS we can under the projects we got sponsored from Ministry of Earth Science. Not only the IIT Kanpur is doing that, but there are many other institutions, mainly the National Seismological Center, Ministry of Earth Science is at New Delhi, is handling most of the deployment of permanent GPS stations in India, and we are also doing some part in Himalaya. Now the aim is to very precisely measure that what is the convergence rate or maybe the plate motion of the Indian plate. Now if you see here, we have like some places we are having very long arrows indicating that the motion is very fast. That means the convergence between the two plate boundaries is very large, and this also has an implication towards the hazard in terms of the earthquakes. Now if you look at this map which shows the relationship of the plate boundaries and the alignment or the orientation, or you can say the locations of the earthquakes. Most of the earthquakes are along the plate boundaries. So this also helps us in understanding that these plate boundaries are dangerous in terms of the earthquake and the hazard associated with it. And not only that, we also are able to learn and understand that the earthquakes which are aligned along the plate boundaries are not occurring at the same depth. We are having the deeper earthquakes which have been marked by red dots. Then we are having the intermediate earthquakes and the shallow earthquakes. So shallow earthquakes are mostly most dangerous one, okay, because as I discussed in one of my lecture where I was talking about the 2015 Gorkha earthquake, there we emphasized upon that what was the focus, that is the depth of the earthquake. It was hardly 15 to 20 kilometers. Now if you come down to India here, we have mostly the collision zone, which initially I explained that the plate, oceanic plate ahead of this continental plate subducted below. So we are having right now the two continents have collided, but still we have the older plate which subducted initially. Hence we are having the collision plate boundary here, but this portion which we are having Sumatra, Andaman and Arakan subduction zone, we have the subduction zone, like one plate is subducting beneath the another one, and mostly what you see here is that you are having the shallow earthquakes. So this is more very much like in terms of the hazard posed by such earthquakes is very high, and the risk is also very high to the people who are staying in this region. Now one more important thing which you should remember is that, and I explained in one of the previous slides in previous lecture, that wherever we will have the one plate subducting below another one, we will have the signatures of volcanic eruptions. So this shows the that the volcanoes are also are in a typical environment, or the relationship between the two plates, you will find that where one plate is subducting below the another one, you will have the volcanic eruptions. Otherwise, you will not see the volcanic eruptions on in all plate configurations. It is difficult because you need to have the source which will melt in the deeper part of the Earth's interior and result into the volcanic eruptions. So again, if you look at this is in subduction zone, so we don't have we have volcanoes here, but we don't have the volcanoes here in this area. Now, plate boundaries, as I was discussing, we have mainly you can say we can classify in three major categories. One is convergent, transform, and divergent plate boundaries. So most movement occur along narrow zone between plates where the results of plate tectonic forces are most evident. There are three types of plate boundaries. One is your divergent plate boundary, which you can see here, this one. So you have a divergent plate boundary where new crust is generated as plates pull away from each other. So we also term this as a constructive plate boundary because there is no destruction which is taking place, and always new plate is been added up. Now, how they came to know that there is an addition of the plate as one moves away from the spreading centers? What they found was that close to the spreading center, I'll just put a line here. So if you move away from the away from the center, then the rocks or the material, the molten mass or the magma which came up, what we found that we have, if you move away, we have older rocks. If you come closer, then you are having younger rocks. Okay. So this was the finding which helped us in understanding that every time there is an addition of crust along these spreading centers. Then we have another one is convergent plate boundary, where crust is destroyed as one plate subduct under the another one, and these are the convergent plate boundaries where one plate, the oceanic plate, is subducting below the continental plate, or you are having an oceanic plate subducting below an oceanic plate. Now, the older oceanic plates will be relatively heavier than the younger one, so this will subduct below the younger oceanic plates. And if you see, the sketch also tries to explain that the subducting plate which has been moving down or subducting down, when it reaches the asthenosphere, there is a melting which starts, and that results into the formation of the volcanic arc or the volcanoes on continental plate or in the oceanic plate, and this we termed as an island arc. And the area close to this subduction are termed as trenches. These are termed as trench, and trench will be the contact where will be the most deepest portion between these two plates and in the area where you are having the plate boundary. So if I put in sketch here, then this is the overriding plate and this is the subducting plate, and suppose you are putting an ocean here, so this will be the deepest part. This is termed as trench. So you can recall if you are asked that what do you mean by trench here in relation with the plate boundaries. Okay. Then finally we have the third one is the transform boundaries, where crust is neither produced nor destroyed as the plate slides horizontally past each other. So this transform plate boundaries are been shown here actually. Okay, I'll just remove this part so that you can clearly look at. These are the transform plate boundaries and they are associated with the spreading centers. Okay. See, these lines here are the transform plate boundaries. So one is your constructive plate boundaries, another is your destructive plate boundaries, and further last one is your transform plate boundary. Now another example is which I would like to add here is of a triple junction where three plates are moving away from one another. So we have three plates here which are been and the area is termed as triple junction. So we have the East African Rift Valley spreading away, this one here. We have another one along the Red Sea. So you have African plate and Arabian plate here, and then we have the area along the Gulf of Aden, which is also moving away. See, the yellow arrows are showing the drifting of the different plates with respect to one another. So the East African Rift Valley spreads the continent apart at the rate of around 100 times slower than typical ocean rift zones. So this process along the African Rift Valley is very slow, but recently this was evident that some areas in this region has splitted apart. If I'll see if I have a movie, then we can show, or maybe in the next lecture we can show that movie where the people have been watching that how things have moved. But of course this phenomena is very slow, and maybe it will take a long time to break this land into two parts, and you will have a new ocean along this boundary. So this rift forms one arm of a triple junction from which the Red Sea and the Gulf of Aden forms somewhat more rapidly spreading rift. So these two are comparatively moving faster than this one. Now coming to this example is very good here, which has been shown as the Dead Sea Fault. Okay. So this I have already explained that if you are having the oceanic plate subducting below the continental plate, then you will have one hazard which is related will be the volcanic eruptions. Another one is that if this moves and we have an water on top of it, so along with the earthquakes, which will be and very like mega earthquakes, we will also have the tsunami, because there will be a disturbance of the water column which is sitting on the top of this. So we have, like in such situations, or the plate boundaries where we talk about the subduction zones, we have threefold hazard which is associated with such tectonic framework. So on the surface also, when you are having the oceanic plate subducting below the continental plate, you can see beautiful volcanic cones or the eruptions which are been seen in along